Thanks, Andy. Good morning, folks. How are you guys doing? Right. The last conference I had gone in, it was all sweet suits and ties, so it feels a lot more comfortable right now, back to the comfort zone. So it's great to be here at the Spark Summit. Love all the energy within it in New York. Walking down the avenues of America is always a fantastic experience. If nothing else, that's what I do every time I come in out here. So hopefully you guys are all having fun out here. Right? So we all know what is eBay. It is a global marketplace. We are the other e-commerce company. We are not bent on world domination. We are truly a global marketplace. You can get a lot of interesting stuff on eBay. You make it really big. All you need is $6 million and you can buy that right off eBay, right? But the more mundane, you actually had this little dongle, you had your Fitbit, you are all ready to work out, you missed the dongle, eBay is always there for the rescue. So what we are is a marketplace with 162 million active buyers on eBay and 25 million sellers. This is what really differentiates eBay from our competitor up north. Is not only do we want to make it as efficient as possible for our buyers, but also we are a platform dedicated to make it the best available for the sellers. We have a total of 800 million listings on our site. We have 8.8 new million listings that are being added on every week. And like the rest of the e-commerce industry, the transition to the mobile has been gradual. More than 42% of the eBay's revenue, which we call as the GMV, actually happens on the mobile devices. There is more than 291 million downloads of the eBay mobile app as of today, right? We have evolved from our auction roots. Today, more than 79% of the items that we have are actually sold on eBay are new. More than 84% of these items are fixed price. That before I joined eBay, I was not aware of that fact. That was a surprise for me too. And 63% of these transactions today actually offer free shipping. The way we evolved from where we started to what we are today is by understanding that data is one of the key assets that we have. There is hundreds of use cases for the data within eBay. I will not go through all of them, so don't worry about that. The one thing I would like to call out, the one investment where we have we are spending a lot of time and effort on right now is what we call as structured data. The initial use case, the initial user pattern on eBay was the search oriented. We had our user profile where they would actually scour through the search listings to be able to find the gem in the haystack. But over a period of time, we have noticed a transition to the quick e-commerce experience. Now the users want to come in, buy the item and go out rather than the search. And for that, we have to actually transition the entire data model that we had within eBay. We have to make sense of the 800 million listings that we have on eBay, convert those 800 million listings into a product catalog, and a product catalog that's constantly evolving. That's not static. There is new product category leaf items that are being invented on a daily basis. There is product categories that are getting deprecated as there is no longer a demand for those items. So that's one of the biggest investments for the last 2 years and a transition of the eBay's data model. There is a lot of investment in the data sciences. There is personalization. every individual user within the eBay site has actually a personalized experience when they come in. There is use cases in merchandising, there is use cases in trust, a big component, and there is shipping. Across the board, there is an understanding within eBay that data is to support the eBay's model. Data, we need to truly unlock the value of the data. And what I would like to introduce now is this concept of a data platform that we built to be able to do that, to be able to handle the volume of the data that we have within eBay. The next few slides, what I'll also be showing is the fact that Spark has been making steady inroads within the components of this data platform. Across the board, you will see dozens of use cases where Spark is the ideal choice as the framework to support some of these components. Within eBay, what we call as the data platform, we are basically looking at 3 separate components. We built out our data warehouse around a decade ago. We started off with Teradata, but now more and more of the data sets that we had in Teradata are transitioning over into Hadoop. Combined, there is close to 200 petabytes worth of data that we store in Hadoop and Teradata combined. So we have one of the largest infrastructures of Hadoop and Teradata in the world today. The other investment that I think is going on across the industry, there is a lot of people investing in this particular concept, is the streams. I know a lot of what Databricks is talking about is also around in the streaming. There, the thinking is, like we consolidated all our data sets in a data warehouse, let's consolidate the streams, every data stream that you have. Let's not have each and every product unit build their own data stream out. Let's actually consolidate that, give the governed shared access to these large streaming clusters, right? And then once you have these, once you have the data at rest, once you have these data streams, build some intelligence around the metadata that you have, build some intelligence on the metadata that's available within Hadoop, within Teradata, within your Kafka stream. So that's what we were calling as data services. So the data warehouse, we had built it out with Teradata. The highly concurrent access to ad hoc users, that's still in Teradata today, and we still believe that's the best platform. But more and more of these data sets are transitioning over into Hadoop. The cases where you are running your large machine learning algorithms, the places where you are running your batch processes still happen mostly on Hadoop today. One of the key concepts there is to make the data available to the consumers. The traditional data warehouse, or the EDW, there was this notion of this ivory tower approach to it. The data was kept locked up in this data warehouse, and if you wanted to make any changes, there was this massive process that you had to go to. One of the key things that we are trying to do is make sure that the data is available to the consumers for experimentation, for ability to innovate, for ability to truly unlock the value of the data. And the next project that we have been investing a lot in is what we call as the data virtualization. To achieve this, the concept there is try to make the access of the data, irrespective of which data warehouse it is, to be uniform across Hadoop and Teradata. The second thing is to make the access, to make the experimentation on these data sets as easy as possible. I should be able to combine the different data sets. I should be able to make I should be able to augment them, not without going through a massive business process to be able to affect this particular change, giving the power to the analysts and the developers to be able to make their own changes. We've been working on this for the past 6 months. I think we are happy with what we have seen. We will soon be open sourcing this data virtualization component. One of the other key things that we've supported out of this is transparently make cached copies across multiple data centers. This has been very popular, especially a lot of our analyst community for the eBay is in Europe and Asia. for them having these data sets that they should be able to modify and be available across these geographies was a useful capability. And another project that we worked that we have open sourced and now it's a top level project in Apache is Kylin. We came to a realization soon that now the OLAP use case, we have enough tools and out there so that the OLAP use case is actually a reality. I should be able to create a cube, a 100 terabyte cube. I should be able to do sub-second responses on billions of 10 billion row data set. As long as I go and materialize the cube and store them. So what we do today, the raw data sets are actually in Hive. We run a cube building process where we materialize the cube and store that into HBase and put a SQL engine on top of it. One of the big things that we have been spending time on right now is to transition the cube building process. Before it used to be a classic map reduced job. Now we have transitioned that over into Spark, and we are seeing a lot of benefits out of it. The other big investment that we have today is the data streams platform. Here the understanding is that anyone within eBay needs access to a streaming infrastructure. They have a centralized place where they can get access to it. I think the industry across the board is quickly standardizing on Kafka as the messaging infrastructure. The thing we started off using Storm as our basic stream processing capability. Now we are experimenting with the recently open sourced Google Dataflow component, and then using the Spark runner within the Google Dataflow and looking at standardizing that as our Storm processing environment. The other key thing that we are doing out in the data streams world is to make sure that we have a whole app development lifecycle associated with the streaming applications. Like your web, in the web world, there is a lot more standardization in how you develop the app, how you test the app, and then how does the app moves into production. Whereas in our Hadoop infrastructure and the big data world, it was a lot more of a wild west out there. So we are transitioning to that mode with the data streams platform that we are building. Once we have got these two, we have tools to be able to search the metadata. So once you have identified all the data sets, I should be able to query my metadata repository for the data sets that exist in Hadoop, that exist in Teradata, that exist on my Kafka streams. We also have the ability to do what we call as collaborative analytics. Once we have identified these data sets, you can use crowdsourcing. The analysts and developers can actually mark certain data sets to be more than others. There is a Wikipedia style collaboration that happens on these data sets. And finally, data governance. I have business glossaries that identify my data sets. I have a dictionary that spans across all the infrastructure that I have, and have the ability these are all the data services provided on the data at rest as well as in motion, right? Once we made Spark available to the community within eBay, the adoption was immediate. We saw a lot of people wanting to build out a lot of their applications in Spark. So we went about and said, let's create an infrastructure that is different than our traditional Hadoop infrastructure. So we have a lot of firsts with the Spark clusters that we have deployed. One of the first things that we did was deploy the Spark clusters in a virtualized environment. We are running them on VMs as opposed to bare metal. The other interesting thing that we are doing with our Spark clusters is the fact that the flavor of the virtual machines, it's the same flavor as our web workload, so the web containers, so there is no local storage associated with these VMs. we are actively going the route of disaggregated storage, where the storage still resides in a Hadoop cluster. The Spark compute is in its own, and we have the networking bubble that allows the fast communication of the data between these two clusters. And again, the application development lifecycle, this is a theme where the Spark applications go through a proper app development lifecycle before they get onto production. The other thing I wanted to spend a little bit of a time on is the data pipelines. What we call as data pipelines within eBay is transitioning the data on the eBay site, everything that happens on the eBay site into the analytics environment. The reason I wanted to spend some time there is, again, Spark is actually seeing a lot of adoption in the data pipelines that we build. The data sets that we capture within eBay, the behavioral, one of the data pipelines is called the behavioral data pipeline. This is all the activity that happens on the site, all the user interactions, as well as the clickstream analysis. We capture that data, we transition that over into the analytics, and we built a quite sophisticated environment within eBay for these data pipelines. The processing of these data sets used to be MapReduce before. Again, that we are transitioning that over into Spark. One example that I wanted to give was the experimentation platform that we built within eBay. Any new site that we deploy, or any new feature that we put on the eBay site, goes through an experimentation exercise. This is the standard A/B testing that we do. The initial implementation of that was done on Hadoop, and we transitioned that over into Spark, and again saw a lot of benefits with that transition. The other data pipelines that we have is the transactional data pipelines. This is the one that we built out first. This is this classic batch-oriented pipelines. This is the end of the day processing, where you capture all of the data at the end of the day, then move them over into your data warehouses. The realization within industry as well as within eBay that we need to get access to the data at a much more frequent pace, and transitioning over into the near real time. So again, we are re-implementing these data pipelines using more the near real time technologies, right? That concludes what I wanted to talk to today. In summary, what I would want to call out is that we have the sophisticated data platform that we built within eBay to be able to process these massive volumes of data. And once we started introducing Spark as the framework, we saw a rapid adoption of the framework. We saw more and more use cases using Spark. And I think I'd see that particular trend continuing. We see a lot more of these components using Spark in the near future. All right, thank you.